5, compound interest. So most interest, there's simple interest and there's compound interest. So most things that actually charge interest or you collect interest on, it's on compound interest. So what does it mean to be compound interest? You want to take a guess? Okay, so if it's simple interest and I invest $1,000 at say 2% a year, that means I'm making $20 a year is 2% of 1,000, right? And no matter what, every year I'm going to make $20, even if now I have 1,020 in the bank. Now I have 1,040 in the bank. That's simple interest. Compound interest, we get interest on interest. So after that 1 year and you have 1,020, now you calculate that 2% on the 1,020. And then it keeps building. So most things, including mortgages, credit cards, compound interest is used. If you don't pay down your whole bill, they're gonna charge you interest on that interest. Whatever's owing, they're gonna charge you interest on top of it. Okay? So it stinks. It totally stinks. So it's interest on interest. That's why it's compounded. So when they charge interest on interest. Okay, so usually you can charge interest on interest, so it can be charged monthly, it can be charged weekly, bi-weekly, semi-annually. What do you think that is, semi-annually? Every 6 months, twice a year. Annually is yearly. And so that's good old compound interest. Now this is a formula you need to know. It's not on your formula sheet. Yay. Okay. So what does that mean? It means memorize me. Okay? You have to know this formula. Now we get used to using it and it becomes pretty simple to use. It's very similar to a times b to the power of x. Okay? But know this formula. So what does A stand for? Accumulated amount. The total amount after the interest is charged, right? The year-end balance kind of idea. P is your principal. So principal is basically the amount invested or borrowed, the amount you start with. So how much money do you start with? R is our annual interest rate, R for rate. N is very important, the number of compounding periods per year. So if here's our N values. If it's annually, it's 1 per year, semi-annually, twice per year, quarterly, 4 times a year, monthly, 12 times a year, and so forth. Okay? Daily, 365 times per year. And then T is the number of years. So for example, if I'm compounded monthly for 2 years, how many compound periods will we have? 12 times 2, which is 24. So if it's monthly for 2 years, it'd be 24 compound periods. And so that's what this exponent is going to be. This exponent is the number of compounds, total compounds. Okay? So that's why we do N times T. So number of total compounds. Okay? And here you'll see R divided by N. So remember, R is your yearly interest rate divided by the number of compounds per year. So that what that means is the interest rate per compound. So if I have a 12% interest rate compounded monthly, what's my interest rate per compound? Okay, so say I have 12% annually compounded monthly. It's going to be 1% per month. Okay, so this value here we get, it's the rate, the interest rate per compounding period. Okay, and once we get that all out and we add 1, and the reason why we add 1 is the 100% plus the interest rate is going to be the value at the end. So let's look at some examples. And they're very repetitive once you get going. Andrew invests $100. Determine the value of PARN and T for each situation. And we're actually going to calculate it as well. An annual interest rate of 4%. So we have A, P, R, N, and T. So we're going to write in everything we know and calculate our unknowns. Okay, so what do we know about Andrew? He's rich because he invests how much? $100. Okay, where does that go? Is that our A, our amount accumulated, or our P, our principal amount? Principal, how much we start out with. So that's 100. Okay, an annual interest rate of 4%. What does that tell us? R. Now we always want to make it a decimal. So what is 4% as a decimal? Divide by 100.04. Compounded semi-annually. So what does that mean? Our N value is 2. 2 times a year. For how many years? 3. Okay, and we're looking for, obviously, how much does he accumulate then? How much is it worth in the end after the 3 years? Pardon me? Semi-annually, twice per year, compounded twice per year. Okay, so our formula is A equals P times 1 plus our rate over the number of compounds to the power of our N times T. And you'll be able to make this formula with just like plugging in the numbers. We become really natural after. Okay, so principal we said is 1,000 times 1 plus. Now here we want to find what is my interest rate per compound. I think you invest 100. Yeah. So our interest rate per compound, well, if it's 4% a year divided by 2, because it's twice a year. So we're going to end up paying 2% per compound. How many total compounds would we have then? If it's twice per year for 3 years, 2 times 3, that's where this comes from, which equals 6 compounds. Okay, so when we simplify this, what does the inside become? So first, 0.04 divided by 2. 0.02 plus 1. 1.02 times 6. To the power of 6, sorry. So let's enter that into our calculator. So what this is saying is I invest $100. They're going to accumulate interest 6 times at 2% per time. So if I were to make a chart, so we have $100 after the first time. What's 2% of 100? $2. So times the 1.06, $2. So 102. Now we take, for another time, I'm going to multiply by 1.02 again. So this formula, so I don't have to go through these motions a million times, but just to give you an idea what's happening, so $102 times 1.02, oops, gives you, now you have 104.04. Now to get the, so that's after 2 compounds, so 3. So this, I'm just showing you what's happening. This formula will give you this automatically. This would be the long way, making a chart. So then I go, okay, my answer times 1.02 again. So now it's worth, after another year, or another compound, 106.12. Oh, it's 1.02, thank you. Times 1.02. So every compound, we're charging 2% interest, right? So it's 4% per year, semi-annually. So each time we're multiplying it by 1.2. What does this give me? Somebody calculate that? Yeah, 100 times, what did you get, Andrew? 112.13? Yeah, round money, 2 decimal places. Thank you. Okay, so if I keep going with this pattern and I did it 6 times, 108 something times 1.06 again, 1.02, 110, and then again. So this is what the formula is doing for us. So we don't have to do this that many times. Okay, it's the same idea. So each time, so it's like multiplying it by that 2% 6 times. And the formula does that for us. Let's try another one. Okay, so let's write our list. We have A, P, N, R, T. So still he's investing how much money? $100. How do you change this to a decimal? 6 3/8%. So you're going to want to change the 3/8 to a decimal first. How do I make 3/8 decimal? 3 over 8, 0.375. So this would be 6.375%. So as a rate, what are you going to write that as? 0 decimal 0.6375. Divide that by 100 because that's a percent. Okay, it's compounded monthly, so N would be 12 for how long? 2 years. So let's make our formula. A equals 100 times 1 plus, what are we going to divide? So our yearly interest rate divided by 12, because we want to find out what's the interest per month. To the power of 24, 2 times 12, because there's 24 compound periods. Now, could you just type this in all at once? Yeah. 100 times 1 plus 0.06375 divided by 12, then close the bracket, to the power of 24. 113.56. You get the same thing? So notice how with this guy, it's less years than the first guy. Right? It's 2 years versus 3, but he's made more money. Why? Because it was compounded monthly. He's building interest on interest. So he's making more money. Okay, do you want to try the next one on your own? Okay, try number 2. So again, start by making your APNRT. Okay, how much was the amount invested? The principal, 500. Okay, invested 500. Number of compounds per year? Compounded annually, so that's once per year. So it's going to be 2 times 1 for 2 years. Time is 2, and your rate is 0.08. So your formula should look like 500 times 1 plus 0.08 divided by 1, because compounded annually, to the power of 1 times 2, or just power of 2. Was that good? So what did that give us? If you're going 500 times 1.08 to the power of 2. 583.20 cents. Right? So you could have also calculated this guy. If it's just 8% annually, you have your 500 times 1.08. Why do they have the 1 in there? Why is there a 1 in the formula? Why is it 1.08? It's So I want my amount plus my interest. So the 100% plus the interest on top of that. So if you're calculating GST on something, right? If I want to know, I have a shirt that's $20 and I want to know the price with GST, you'd multiply it by 1.05, right? Because that'll include the 20 plus the 5%. You know that? So when you want to calculate tip, you have your total, and I want my 15% with tip, I times it by 1.15. There's how much I should tip. So that's the amount it would be with tip. Not how much you should tip, but so I should put $37 in the pot. Right. If I wanted just the amount I should tip, it would be 0.15. Yeah. Okay. So, read this one carefully. Suppose we'll invest 1,000. What's 1,000? P, your principal, for 10 years, which is our T. If he earns an annual interest rate of 7.75%, R, compounded monthly, that's my N. Determine the total interest he earned over 10 years. Total interest. Okay. So our formula, does it give us the interest earned? So it wants just the interest earned. How could we get how much interest he earned? A minus P. Yeah. So your interest that you earn is equal to your total amount collected minus the amount you invested. So once we get our answer for A, let's make something cool here. Creative pen. Let's get creative. Yeah? Interest earned, oh, I should add ED there, hey? Earned, interest earned. Okay, so we still need to find A. So what's our p-value? 1,000 times 1 plus what divided by what? 0.075. So my yearly interest rate divided, 775, thank you. Divided by how many compound periods a year? It's monthly. 12 for monthly to the power of how many total compound periods if it's monthly for 10 years? 120, 10 times 12. Okay, we can enter that in. 1,000, and you can type it as you see it. It's kind of nice. Over 12 to the power of 120. If you actually wanted to type 10 times 20 in your exponent, then it would have to be in brackets, that part. Or 10 times 12, right? Usually we can just calculate the exponent in our head. 10 times 12, 120. If you wanted to keep it together, then you would actually have to keep brackets there. Okay, so, ooh, you made some money. Okay? Well, 10 years, I guess. Monthly So A was 2,165.19. So how much? So your interest equals how much I'm total I have in my account at the end minus how much I invested. So he earned 1,165.19. Not too shabby. Okay? Not so bad? Okay, but see how it's related to exponential functions? So we could ask questions where, how long? Okay, that's our next progression. So let's look at a question like that. Michael has an opportunity to invest some money for 5 years. So 5 years would be which letter? A, P, N, R, T. T is 5. Compounded quarterly, what's that? 4 times a year, so N. 6% annually is R, 0.06. How much does he need to invest? So who are we looking for? P, so that he accumulates or has 5,000 in 5 years. So now we know how much he is going to make, like the final amount in his bank account. How much does he have to invest? Okay, so what does our formula look like now? 5,000 equals P, or X, we'll call P, times 1 plus 0.06 over 4 to the power of 24 times 5. Okay, so if 5 was our unknown, how many years? It'd be 4x, or 4t. Okay, so could we figure out what this guy is first? Yeah, let's do that. So in our calculators, we're going to type in the other side. I want it to be a little bit simpler. To the power of 20. Okay, don't worry about exacts this very moment. So we can replace all of this with 1.34686. I don't remember what I said out loud. Is that right? 3, 4, so close. 6, 8, 6. But rounded, yeah. Doesn't matter, but because we're going to use our exact value in our calculation. So what's our next step? We're going to divide both sides by, yeah, because we have multiplication, opposite operation. It's our division. Now, how do I make sure this is an exact value answer? Yeah, second negative. So 5,000 divided by my answer, second negative. Okay, so here we're using second negative to use answer. So what does that give us? Did you get the same thing? Yeah. And with money, we round to what? Nearest hundredth cents, yeah. 3712.35. I forget what I said. 35, thank you. So what does this mean? He has to invest this much to make 5,000 in how many years? 5 years, compounded quarterly. Okay, so last question I want you to try on your own. So, AP, NRT. Tell me what you know. What do you know? A, 25,000. Okay, you don't know how much you have to invest. What else? 0.05625. Is that right? Yeah. Your R value is, oh, oops. R is here. N is what? How many compounds per year? It's monthly, so 12. And how many years? 8. Okay. So we have 25,000 equals P times divided by 12 to the power of 12 times 8, 96. 96. Okay, so you punch that into your calculator. 1.56 blah, 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 blah. Yeah? And we divide both sides by 1.56 blah, 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 blah. And you get, I have to invest how much? 47 is our principal. Okay, so that is it. Now, sometimes, one more note I need to talk to you about really quickly. Sometimes you might see the formula given like this. If you see the formula like that, they're just saying this is the interest per compound period, so you still have to do the division, and this would be the total number of compound periods, so you still would do the multiplication. Okay, yeah, so you'd still have to work it out. The other one formula is nicer because it shows you right then and there. I need to divide here, multiply there. All right, so all of 6.5 is homework. It's not so bad once you get going. And that's this unit. I know, I'm trying very hard to be hated.